Here's an example of how you can find limits when you're given a graph. And so we're first going to look at the limit of f of x as x approaches -2. And remember, what we're looking for is for the left and right hand limits to actually equal the same value so that that limit can exist. And so I'm going to do it for this one. And we're going to check here the limit as x approaches -2 from the right for f of x is actually -1. And then the limit as x approaches -2 from the left for f of x, well, if you look at the graph, we actually don't have any information about what happens there. So we don't know. But the right-hand limit exists. And so when we're making our conclusion about the limit existing at x equals -2, we say it does not exist. So now we're going to look at the limit of f of x as x approaches 0. And so as we're looking at the graph, if we look at the right-hand limit, we have a value of 0. And if we look at the left-hand limit, we have a value of 1. And since those values are not equal, the limit as x approaches 0 for f of x does not exist. Now let's look at C, the limit of f of x as x approaches 2. And so if we look there, the right-hand limit gives us a value of -2, and the left-hand limit also gives us a value of -2. Even though there is a hole at x equals 2 for the graph of f of x, the limits can still exist because we're just looking at what happens at values just to the right and just to the left of x equals 2. So we're going to say the limit of f of x as x approaches -2 is equal to -2. And then finally, the limit of f of x as x approaches 4 turns out to be very similar to the conclusion we made for part A. We do have a limit from the left here. That's 0, but we don't really know what's happening from the right, so we're going to say that limit also does not exist.